Have a nice day, everyone. Welcome to the lesson tutorial for grade 8 math lessons this quarter 3, week number 2 with the topic Axiomatic Structure of a Mathematical System, Postulates and Theorems. This lesson includes most essential learning competency number 36, which states that the learner illustrates the need for an axiomatic structure of a mathematical system in general and in geometry in particular, postulates and theorems. For learning task number 1, in which you're going to answer, suppose you decide to participate in a group research project for a new hair growth product the company is testing. When you go to the group meeting, the first thing you have to do is fill out a questionnaire asking for your initial hair length before using the product. As you're all doing this, a woman in the group, Angie, states that she has the longest hair in the group. You take a quick glance around, and it looks like she does have the longest hair of all of the people in the group. Now, are you going to accept her statement as true? Or are you going to get a tape measure and measure the length of everyone's hair to verify the truth of her statement? Answer the following question. Number 1. What statement in geometry is being accepted as true without proof? Number 2. What statement in geometry is being proven as true? For learning task number 2, answer the following also. Number 1. How is a postulate different from a theorem? Number 2. Why are postulates and theorems important in geometry? Number 3. What real-life situation illustrates postulates, theorems? Let us have the definition of some important terms in this lesson. Axiom or postulate is a statement or rule that are accepted or considered to be true without proof or validation. Point existent postulate. Every plane contains at least 3 non-collinear points. Every line contains at least 2 points. Space contains at least 4 non-coplanar points. For line postulate, this states that for any 2 different points, there is exactly one line that contains both points. Line intersection postulate. If 2 lines intersect, then their intersection is a point. Plane postulate. Any 3 points lie in at least one plane, and any 3 non-collinear points lie in exactly one plane. Flat plane postulate. If 2 points of a line lie on a plane, the entire line lies on the plane. Plane intersection postulate. If 2 planes intersect, then their intersection is a line. Angle addition postulate. If point D is in the interior of angle ABC, then the measure of angle ABC is equal to the measures or the sum of the measures of angle ABD and angle DBC. Supplement postulate. If 2 angles form a linear pair, then they are supplementary. When we say supplementary, the measure of the angles is equal to the sum of the measures of the angles is 180 degrees. Equality properties. They are also used not only in solving algebra, but in proving theorems, especially in geometry. First, we have the reflexive property. For every real number x, x equals x. For symmetric property, for every real number x and y, if x equals y, then y equals x. Transitive property. For every real number x, y, and z, if x equals y and y equals z, then x equals z. Addition property. For every real number x, y, and z, If x equals y, then x plus z equals y plus z. So in this, same number is added to both sides of the equation. Subtraction property. For every real number x, y, and z, if x equals y, then x minus z equals y minus z. So the same as in addition property, same number is subtracted from both sides of the equation. Multiplication property. For every real number x, y, and z, if x equals y, then x times z equals y times z. So in here, both sides of the equation are being multiplied by same number z. Substitution property. For every real number x, y, and z, if x equals y and x equals z, then y can be substituted to x, therefore y equals z. Theorem. Theorem is a statement proved to be true using postulates, definitions, other established theorems, and logic. Given a line and a point not on the line, there is exactly one plane containing it. Segment F contains its endpoints E and H at plane M. Thus, if point G is on plane M, then H and G are coplanar. Therefore, a line and a point determine a plane. Every segment has exactly one midpoint. For every point corresponds a unique positive value. Thus, every segment corresponds a unique value of distance or length. As illustrated, given a segment with length 8, its midpoint, by definition of midpoint, is at 4 since 8 over 2 is equal to 4. If two intersecting lines form one right angle, then they form 4 right angles. By vertical angle postulate and linear pair angles, if the measure of angle GHD equals 90 degrees, then the measure of angle AHD is also 90 degrees. Thus, the measure of angle AHD equals 180 minus the measure of angle GHB equals 90 degrees, and so with the measure of angle BHD, which is also equal to 90 degrees. Two lines perpendicular to the same plane are coplanar. AB is perpendicular to BG through point existence postulate. Vertical angles are congruent. Supplements of congruent angles are congruent. So you may now answer or continue answering learning task number 4 for your practice exercise. So learning task number 5 on page 8 of supplementary materials for G8 Mathematics will also be answered. And then after that, you may now answer the assessment tool, assessment 3.1, which has been uploaded in your Google Classroom. So that's all, and thank you for listening.